As I said, the next two examples, we're going to use the result of the previous four example, the integral of the tangent, cotangent, secant, cosecant, as reference. So I think I'm on page 3. And this will be example number 5. Okay. We want to, already 5? 1, 2, 3, 4, yep, 5. Okay, here's what I have for you. What about the integral of tangent cube of theta d theta? Okay. Now I cannot use the combination tangent theta secant theta because I don't have the secant. Remember, I need to have either the secant squared or the secant. Many. I agree. That would be a good starting point. So we're going to say that the integral of the tangent cube, I can write it as the integral of the tangent squared times the tangent. Okay, so what do I do with the tangent squared? We have a solution for the integral of the tangent. Well, quotient identity. Then I need to, this will give me two more functions, sine and cosine, and I'm not losing, well, I lose the tangent, but it will be sine cube over cosine cube. Messier. Try something else. Not quite, not yet. I'm not ready for this yet. Secant tangent. I don't see a secant. Ooh, you started well, and then you strayed off the straight and narrow path. So we recall first that the Pythagorean identities. Remember, the secant squared, that's what I heard you saying, is 1 plus tangent squared. What shall I substitute here? Tangent squared. Somebody mentioned the secant. You're right, we are dying to have the secant in the mix, right? So the tangent will be the tangent squared will be the secant squared minus 1. So this is a very important identity. Now, what happened is we're going to say that instead of the tangent squared, I'm going to substitute the tangent squared with the secant squared minus 1, still multiplied by the tangent, and you can see where we are going from here. Because if I clear the parentheses, I'll have two integrals, right? One integral will be the secant squared times the tangent, and the other integral will be simply the tangent. Now we know what's the solution here. We just did it a few minutes ago. What about the first one, though? Okay. If I rewrite this a little bit differently, you can see where I'm coming, where I'm going with it, not coming. I'll write it as tangent times the secant squared of theta d theta. Okay, look at the first integral. What do you see? I'm sorry? Okay, but try to, how about if I split it into these two? What do you see now? if this is u, what is this? What's the derivative of the tangent? So this is du. Okay? You want to see something like that. So really what you see is the integral of u du. This one we know the solution, right? The integral of the tangent is the natural log of the secant, right? Plus c. So we'll have that. All we need to do is work on this one. Actually, let's leave the c because we still have an integral here. So c will be the combination of all the constants. So I don't need to put the c here at this point. The result of this integral is u squared over 2, or 1/2 u squared, or it will be 1/2 tangent squared of theta minus natural log of secant of theta plus c. Isn't it a nifty solution? Okay, so you can see stuff is getting a little bit more involved, but we use the fact that we already solved the integral of the tangent, and we use the fact that we have tangent times secant squared, and secant squared d theta is the derivative of is the differential of the tangent.